Hi, this is Captain Chaudhari. In my series of videos on basic stability calculations, I was doing the moment of inertia and center of pressure. We did center of pressure of regular shapes. Now curvilinear, we under curvilinear did a question whereby the ordinates which were given were parallel to the reference axis, that is parallel to the water level. Now we are going to do a question whereby the ordinates will be perpendicular to the water level. Say this is the sounding pipe, it's overflowing, water is overflowing, and let us say you have so many ordinates. The height of ordinates is 0, 4, 6, 7, 6, 4, 0. In the question it would be described as the end bulkhead is curvilinear and the vertical ordinates below the tank top are 0, 4, 6, 7, 6, 4, 0 respectively, and the uniform interval between the ordinates is say 2.4 meters and height of the sounding pipe is 3 meters. Now we have to have a format in which we will take care of this situation whereby the ordinates are perpendicular to the reference axis or perpendicular to the water level. So the table will have y, that is the ordinate. We'll write down the ordinate 0, 4, 6, 7, 6, 4, 0. Now the number of segments are 1, 2, 3, 4, 5, 6. Number of ordinates are 1, 2, 3, 4, 5, 6, 7. Number of segment is 1 less than number of ordinates. So when number of segments are even in number, we can use rule number 1, and that would be 1, 4, 2, 4, 2, 4, 1. This is Simpson's multiplier. Next we have y dx, and remember the key as y dx, and that would be the product of first two columns 0, 16, 12, 28, 12, 16, 0. And hereafter we don't have lever, because in the previous type where the ordinates were parallel to the reference axis, we had the concept of lever. Column number 4 was lever. Here there's no question of lever. This column is for moment of area, and I would write it as y square dx. That means it is the multiplication of the column number 3 and column number 1. 0, 64, 72, 196, 72, 64, and 0. Last column, that is the fifth column, is y cube dx. Y cube dx is the product of column number 4 and column number 1. 0, 256, 432, 1372, 6 into 7, 432, 64 into 4, that is 256, and 0. Let's find out what is sum 1, sum 2, and sum 3. Sum 1 is 84. Sum 1 is 84. Sum 2 is 468. And let us find out what is sum 3. $2748. Now there is no now here we have sum 1, sum 2, and sum 3. Now the area of the bulkhead, that is the curvilinear part, is found as, because this is, we are using rule number 1, and rule number 1 is h by 3 Now because we are using rule number 1 is h by 3 141 rule. So we have used that rule, and the area is h by 3 into sum 1. That is 2.4 upon 3 into 84. So that will be 0.8 into 84. 67.2 meters square. 67.2 meters square is the area. Moment of area about the flat part. Now all these ordinates, they are ending up in curvilinear curve on one side, that is over here, here, and the other side is flat. So here what I tell the students is, you can remember that the moment is taken about the flat side. So we say moment of area about the flat side. So moment of area about the flat side is equal to half into h by 3 into sum 2. Sum 2 is 468. Now this half I have introduced, this comes from the basic formula. We are not doing the proof right now, but please remember, whenever the ordinates are perpendicular to the reference axis, for the moment of area there is an introduction, there is an inclusion of this half. Right? Not to forget this, otherwise the entire numerical will be wrong. Right? So this is 0.4 here. So 0.4 into 468 gives me 187.2 meter cube. So this is moment of area about the flat side, and this is the area. So if I divide 67.2 from this, what I get is the position of centroid with respect to the flat side, right? So that's going to be 187.2 divided by 67.2 gives me 2.786. 2.786 is the geometrical centroid from the tank top, and therefore with respect to water level you can say I will add 3, so it becomes 5.786 meters, the position of geometrical centroid from the water level. Next we are going to find out what is the moment of inertia about the water level. So moment of inertia about the tank top, right? I can write it here. Moment of inertia about the tank top is equal to, now the rule is h by 3 into sum 3, that is 2748. But from the formula we need to multiply this with 1 upon 3. So once again, please remember, wherever the ordinates are perpendicular to the reference axis, to find out the moment of inertia, I include or I introduce 1 by 3 as a constant, and then the calculations will be correct, right? So it is 2.4 upon 3 into 3 into 2748. That is 2.4 into 2748 equals divided by 9. That gives me 732.8. 732.8 meter raised to 4 is the moment of inertia about the tank top. So moment of inertia about the water level would be 732.8 plus area. How much is the area? 67.2 in the bracket plus d1 square minus d square. You know, the distance from here to here is 2.786. Here to the centroid is 2.786, and from here to the water level is 5.786. So 5.786 square minus 2.786 square. So this will be the total moment of inertia about the water level. If we simplify 5.786 into 5.786 is 33.48. This is 33.48. 2.786 into 2.786 is about 7.761. 7.76. 2461 is the moment of inertia about the water level divided by area, that is 67.2, multiplied by depth of the geometric centroid below the water level, that is 5.786. Let's see, 2461 divided by 6.329. 6.329. So 6.329 is the position of center of pressure below the water level. As you know, geometric centroid was 5.786 meters below the water level, and the center of pressure is 6.329 below the water level.